sixth grade, our objective today is to talk about greatest common factor. There's two different ways to find the greatest common factor, so we will discuss this today. Before we do that, as always, we need to go over our warm-up, go over homework, and then I want to finish up prime factorization with monomials, and then we'll get into GCF. So let's quickly go over our warm-up, see how you guys did. Okay, 1, 2, and 3 on page 5 ask you to write the factors. So Doug, we'll start with you on 45. We need not prime factorization, you need the factors. You need the factors. So like 9 times 5, 1 times 45, 15 times 3, okay? So when it says factors, you just need to list the sets of factors, not the prime factorization. Okay, Alyssa, how about 60? Oh, I know what you, okay. I was actually going to show you guys. Okay, go ahead. 1. Go ahead. So what did you say after 15? Okay, keep going. I know you guys are confused. Hold on. Okay, this is how I do it. Okay, ready? So if you're all sitting there like, whoa, what is she telling us? Here's what she did. And this is what I do. 1 times 60 is 60. 2 times 30 is 60. 3 times 20 is 60. 4 times 15 is 60, and etc. Now, I like that way. You don't have to do it that way. Your book does it this way a lot. I am also okay with you guys doing it this way. Alyssa? And I'm okay with one or the other. You don't have to do both. Okay, wait, raise your hand. Go ahead, Emma. I just did. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. That's why I lined them up. Okay? Annalise. Yep. Yeah, you guys all learned it different ways, so I'm okay. As I just said, that's fine. Charles? Yeah. Yes, that's a good way to check it. Yeah, that's a good point. Charles, yes. Okay, what about 29? Adam? Okay, it is prime, so what's the only factor? Good. So for 29, it's 29 and 1. It is prime, so I'm just going to write above it prime. Remember, prime number, the only factors are 1 in itself. Okay, Briar, number 4. No. Matt. Okay, why is it composite? So it has 2 sets of factors. I'm just going to put a C for composite. That one's tricky. Now you can use your divisibility rules. Alyssa? Oh, well, there you go. Glad you remembered that. Okay, good. Okay, number 5, Justin, prime factorization of 100. Good. 2 squared times 5 squared. And then the number 6 we did not get into very much yesterday. We're going to do more today, but I want to see how you did. We need the prime factorization of the monomial. Emma H. Good. Awesome. Emma M. You can, but remember yesterday, I prefer if you have it in exponential form, but it's okay like that. Jeremy? Remember from yesterday, we talked about variables should just be written out, but if you keep them in exponential form, I'm okay with it. Okay? GCF and LCM are different. You'll see that today, but for this kind of problem of just writing out the factors, you should list them all. Okay? Sean? Yeah. Yep. That's why I said that. You can use your divisibility rules now because it's a factor of 7. Annalise? Okay, then let's hold off on that. Okay, we need to stay on topic. Any other questions on 1 to 6? All right, let's go to, what was that? Page 3 was your other warm-up. Okay, this is kind of interesting. I know you guys were like, what? I have to draw something? So let's talk about that. Number 1 said, write 18 as a product of 2 whole numbers in all possible ways. So Adam, what's one way to write 18 as a product of 2 numbers? Good, 1 and 18. Briar, what's another way? Good. Annalise, what's the other way? Good. All right, so part 2 says, use the factors to find the rectangles that have an area of 18, that have whole number dimensions, and then label the given rectangles. What is a rectangle that's 1 by 18 going to look like? 1 foot by 18 feet. What's that going to look like, Briar? Good. So it's going to look like this, right? You guys should have drawn them so that they kind of matched up with their dimensions. So there's the 1 by 18 rectangle. The 2 to 9 one, 2 by 9. Doug, what's that going to? Good. Well, let me start down here. Something like this. I'm not a very good person to draw things. Okay, so kind of like that. And then what about the 3 by 6? Mary? Yep. Yep. So do you guys get kind of the point of that? They just wanted you to see the difference of, all right, there's all these different factors, but the rectangles are going to look very different. So if you were, trying to design maybe like a yard or a fence for your dog, would this be a very good yard? No, that's really, really narrow. That would be kind of annoying. This would probably be the best thing. So depending on what you're constructing, if you think of all the different dimensions, you want to make sure you use your common sense. What's the best possible design for something? This wouldn't be very good for many things, unless you're building a lap of a swimming pool. You just want to practice swimming back and forth, back and forth. That might not be fun either. Or running, yes. Matt? Yeah, we're not worrying about that right now, okay? All right, any questions on the warm-up? We're going to focus, okay? Okay, let's go over homework, and then I want to go back to those notes. Okay, I'm going to read over 1 through 6, because these ones are pretty straightforward. If you wrote them like Alyssa did on 1 through 6, where you just wrote them out, I'm okay with that. But let me just read the sets so you guys can check them. I'll wait till you're there. Okay, number 1, 1 and 28, 2 and 14, 7 and 4. If you list them out, that's fine. Just check your work. Number 2, 1 and 34, 2 and 17. Number 3, 1 and 44, 2 and 22, 4 and 11. Number 4, 1 and 46, 2 and 3. 2 and 23, sorry. Number 5, 1 and 59. Number 6, 1 and 65, 5 and 13. Whilst people are still checking, who can remind us of the difference between composite and prime? Briar? Awesome. Good. Okay. Number 7, Justin. Good. Prime. Doug, number 8. Good. And I just put a, wait, sorry. No. Number 8 is prime. Okay, 8 is prime. I use just P's or C's on these. Number 9, Donatus. Composite. Jeremy, 10. 11, Emma M. Briar, 12. Oh, you don't. Oh, did you find it? Oh, okay. Never mind. 12 prime. I was like, whoa, I forgot you didn't have it. Mary. 7 times 19. That's another 7 roll 1. The 7s are tough because even for me, I have to think about that. They always look like they're prime when you get into a bigger number that 7 goes into, but they're not. Yeah, yes. 7 times 19. Annalise. Yeah. Use your divisibility rules. All right, 13 should be 2 to the third times 31. So I circled in green what you should have filled in. Well, sorry, did not circle in green what you should have filled in. I highlighted in blue, it's just really hard to see. You should have an 8, and then a 2 and a 4. The order doesn't matter of the 2 and the 4. And then a 2, and a 2. Yeah, the 31 was already there, though. I don't know why I circled this. This should not have been circled. Anyways, Annalise? You get the same answer. Yeah, I guess because they have 2 lines there, but this is because they kind of like spoon-fed you guys through this. Typically, the order doesn't matter. It's because they had the 2 lines there. It won't, this is the only time you'll see a problem like this. It's too easy for you guys. Jeremy. That's just how the book does it. I don't like doing it that way either. Okay, 14. You guys needed to fill in a 3 and a 4, and then a 3, a 2, a 2, and that was it. And then the prime numbers or the prime factorization should be 2 to the third times 3 to the second times 5. Okay, Mary, what did you get for 15? 2 to the what? You need to write the prime factorization. So did you break 56 down into 2 times 28? You just broke it down into 2 times 23 by accident? Okay. Nope. Yes, I can't read my writing. Yes, 2 to the third times 7. Okay, Emma M. Oh, that's okay. As long as you have this. This is what I'm concerned about. Okay. All right, Emma M, since I'm on you, number 16. Good. Mary, did you read the next one by accident? Or no, you just messed up on 15. Annalise, 17. Good. Sean, 18. Good. This is at times. It's just really messy. Good. 18 is 7 times 11. Zach, 19. Good. Matt, 20. Good. Justin, 21. Good. Doug, 22. No. Emma M. Good. 3 times 2 times 19. 23, Alyssa. Good. 3 to the third times 2 to the second. And then 24, Adam. Good job. Okay, that was all I had you guys do. So any questions or repeats before we finish up the prime factorization from yesterday? Annalise? Emma M? No, it's 2 to the fourth. Because 16. If you just do 2 times 2 times 2, you get 8. If you keep it as 2 to the third, it's 8, not 16. Okay? Okay. Mary? Your call. Notes or extra. That's something I would hold on to for the whole year because it's good to have as reference. It's up to you. Notes or extra is fine with me. Annalise? Okay, 27 should be 2 times 2 times 2 times 3 times z times d. Okay, anyone else questions on the homework from yesterday? All right, let's go back to our notes. Back to page 3. I just want to finish up a couple things, and then we're going to go on to GCF. Okay, so back to the notes, page 3. We're going to go to example 2. If You already did it, that's okay. All right, so now this should be pretty easy, but I just want to make sure we're all masters at this and experts. Okay, write the prime factorization of 420. What would you guys like to start with breaking it down into? Briar? Yeah, to me, if it ends in 0, I'm just going to easily start with 10. I just think it's, you don't have to really think about it, just write it down. Okay, what do we want to change 42 to? Justin? I agree. 7 and 6. What about 10, Matt? Good. 5 and 2. Okay, what else can we break down further? Alyssa? Into? Good. Okay, what can we circle because they're prime? Briar? Awesome. So what is our prime factorization listed, written in exponential form? Emma H. Good. And that's interesting. You wrote the numbers in order. Do you always do that? Okay. I typically write them in order, like from left to right, from smallest to largest. I just think it looks kind of a little bit neater. Mary? Yeah, I told you yesterday. You're fine. Ladder method's fine. I just always do it this way because a lot of people prefer this way. But like I said yesterday, you guys do not have to do things the way I do them. I just want you to learn the concept. So like Mary, for example, she understands and likes that way better. Go for it. If you're getting the right answer, I'm not opposed to that. Okay? Annalise? Then you probably did it wrong, and I would suggest using this method. Okay? Did you do, what method did you do on your homework? Okay, well, I'm not, just because of time today, I'm not going to do both on these. With GCF, I'm going to do 2 different methods, Annalise, so I'll come look at yours later if you want. Yeah, to 5 and 2. Did you start it with 42 and 10? Okay. Yeah, the 10 needs to be broken down into 5 times 2, so maybe that's the only problem that you, is that, I'll look at it in a couple minutes. Emma. That's, yeah. Yeah. Yeah, you guys can start with it. Like I said yesterday, you can start with any numbers you want. You're still going to get the same prime factorization. Yes. There are a lot of ways to do this. That's why it's hard for me to check every single person's to get through what we need to get through. All right. Let's go to factor the monomial as I'm throwing my note packet. Okay, 24x to the 4th y. Zach, what do you want to change 24 to? Good, 6 and 4. Briar, what should we change 6 to? Good. Adam, what should we change 4 to? Good. Let's circle what's prime, then we'll go to the variables. Donatus, what's prime? Okay. What are we going to change x to, Sean? Or x to the 4th? What are we breaking that into? Okay, what are we changing y to, Doug? Good. The prime factorization is 2 to the 3rd times 3 times x times x times x times x times y. Pretty exciting, huh? Emma M. I'm okay with that. Yeah. And even if you write the x as x to the 4th, I'm not going to mark it wrong because you'll see GCF and LCM get to be a little bit confusing with the variables. So, Mary. I will not do that to you. Okay, I won't do that to you. Unless you guys really make me angry, then I might put like x to the 80th. I'm just kidding. Okay, I'm kidding. Give me a thumbs up, thumbs up, thumbs down on that lesson, just from yesterday, and we finished it today. Okay, we're going to skip the closing because you guys are doing well. Let's fast forward over to page 6. Yep. All right, on to GCF. So before we take some definitions, what do you guys know about GCF? Charles, what do you know about it? Awesome. So what would it be? It is 12. Good. So GCF means greatest common factor. It's the largest number and or variable that goes into both numbers. There are two ways to do this. All years of teaching this 6th grade accelerated course, every class has always liked one method, so I'm going to see what you guys like. I'll show you two methods, and then whatever majority prefers, that's how we'll do it in class. But there are two ways to do this. Adam, you want to add something to the definition? Okay. All right, so let's start with a couple definitions, and then I'll go through the examples with you guys. So common factor, a whole number is a factor of two or more non-zero numbers. Yeah, you're always more than welcome to do that, because when you guys go to college, you're going to have professors writing a ton of notes in the front of the classroom. You copy down whatever is best for you. Starting here. That's why I grade your note packets. I want you guys to be good at taking notes. So yes, change what you want. Just like we do examples in class, write down whatever method you prefer. Okay, GCF, greatest common factor, as Charles said. The greatest whole number that is a factor of two or more non-zero whole numbers. The greatest whole number that is a factor of two or more non-zero whole numbers, commonly referred to as GCF. When you guys take SATs when you get to high school, this is a big part of it, an LCM, but you'll see it with monomials. And basically, like I think it was Annalise that asked that, you'll learn about polynomials in algebra, and that's when you'll really learn more about monomials, binomials, trinomials. All you need to know for this year, they're so exciting. All you need to know for this year is a monomial has numbers and variables. And of course, I like to challenge you guys, so I'm going to add in a lot of the monomials so that you get good practice with GCF. Doug, is this related? That's good. Is this related? Okay, good. Good. You can ask your question. Yes. 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 I prefer that. Yes. As long as you understand what you're abbreviating. All right. Back to the word prime. So now there's something called relatively prime. Have you guys and girls heard of that? Okay. Relatively prime is when two numbers have a GCF that is 1. So basically, it's when two numbers, such as 4 and 13, the only thing they have in common is 1. That's boring. That's easy, right? The answer to that is relatively prime, because all they have in common is 1. So if two numbers only have a 1 in common, they are known as relatively prime. Charles? Yes. Yes. Well, unless, yeah, if the little one goes into the bigger one, then they're not relatively prime. Do you know what I mean, Charles? Yeah. Yeah. So relatively prime. So I use the symbol RP for this. If you don't like that, you can write it out. Zach? Say that again? Then they're not, right, then they're not relatively prime. That's what Charles was saying. So that little number goes into it, you know, but the bigger one then would not be prime. Correct. Annalise? Oh, we're going to do a hard one eventually. Okay. Okay. You're ahead of me. We are going to do them. Just give me some time to get you guys. Let me get you to understand GCF first, then we'll do a word problem. Okay, so just like Annalise said, I'm going to skip this word problem for now because I want to teach you GCF. We'll come back to it. Okay, let's start with number 1. And there's 2 methods. So you don't have a ton of room, but if you could write small enough, actually, don't write yet. Put your pencils down. Let's do both methods together, and then we'll take a vote to see which one you guys like better. How about that? So just watch me for now, and then I'll give you time to write down the method that you like. All right, so let's start with method 1, okay? Method 1 is we need to list all the factors. So I'm going to start with 1 and 54. Who can tell me the next one? Mary. Nope. Okay, Sean, what's the next one? Okay, you'll get it, Mary. What's the next factor, Alyssa? Nope. It's okay, I put you on the spot. So, Mary, this is what we did at the beginning of class. 1 times 54, 2 times 27, 3 times 18, 6 times 9 are all 54. We're listing factors. This is method 1. All right, method, okay, let's go to 81. 1 and 81. Who can give me the next factor? Sean? Good. Annalise? Good. 9 because, why is it just 9? Emma H? Yeah, 9 times 9. You just put one of them in there. All right, GCF. What is the greatest common factor? Briar? Yeah. Nice and easy, right? All right, so using method 1, and don't write these down yet, the GCF would be 27. All right, method 1. Questions on method 1? Okay, method 2. What do we want to break 54 into? Justin? Zach, what do we want to change 27 to? Adam, break 9 down into? Okay. 81, Charles, what do you want to start that with? 9 and 9. Okay. GCF, you want to circle the prime numbers that they have in common. So, what prime numbers do they have in common? Briar? How many? Okay, how many 3s do they have in common? GCF, what do they have in common? How many? On each side do they have in common? Good. 1, 2, 3. 1, 2, 3. Oh, wow. That was pretty funny. You guys all did that at once. What else do they have in common? Do they have anything else in common? Emma? Is 9 prime? Okay. The GCF, which I'll call this is 3 times 3 times 3, which is 3 cubed, which is 27, which matches up with method 1. So, using the factor trees, all you do is take the prime numbers that they have in common, and you multiply them. Annalise. Okay, did you hear what I said? You take what they have in common. Does this side have 4 3s? No, you take what they have in common. It's kind of like over here. Why don't you take 81? Because this one doesn't have an 81. You have to take what they have in common. Mary. I know. Okay. So I'll tell you what I think in a little bit, but I want to take a vote. Which method you like better? So method 1, raise your hand. Method 2, raise your hand. Wow. All right, so here's what I want you to do. I do not care what method you use. Take the one you like, write it down, for example 1. Go for it. If you like both of them, whichever one you can do faster maybe. You're pretty good at listing them. The only time I worry about method 1, Alyssa, is if you forget a set of factors, you're going to miss it. With the factor trees, there's no way you can miss a factor tree. So you make your decision, though. I like the factor trees better, so I'm a little bit more skewed to this. To me, it's faster than thinking about all of these. All right. Your call. Your call. Pick the method you want. Go ahead and write it down next to number 1, whichever method you like. If you're doing the factor trees, make sure you circle what they have in common. No, this is the one we just did right here. Oh, Well, good, because I taught you 2 now, so now you have 2 options. We just did 1. All you're doing is copying down 1. Pick the method you like, copy down what method you like. No, we're going to do it together. Wow, you guys like this. All you had to do was copy down number 1. Hey guys, all you should be doing is copying down the method you like for number 1. We're going to do it together, but if you want to do it, that's fine. You guys seem to like this. You guys might think this chapter is pretty easy then. Wow. That means we should make a dance about it, a GCF dance. Mary's making up a dance. Emma likes equations better. Don't worry, at the end of the year, we'll have a game where we practice all this stuff. We'll talk about what you guys liked and what you didn't like. All right, so let's go to number 2. What I'm going to do is, since the majority of you liked the factor tree method, I'm going to do it with the factor tree method. However, if you prefer the other method of listing the factors, if you don't get the same answer as us, tell me. And in this case, I will do both methods quickly up here, okay, in case you don't get it right. All right, so let's do 12, 48, 66. The question is, find the GCF. All right, Donatus, what should we break 12 down into? Okay, break 6 down into 2 times 3. Adam, what do we want to break 48 down into? 24 and 2. Zach, what should we break 24 into? Say that again. Okay, I was like, whoa, wait. 6 into 2 and 3, 4 into 2 and 2. Okay, Annalise, what do we want to change 66 to? 11 and 6. Okay, let's start with, can someone give us one prime number that they all have in common? Let me get my little highlighter. Sean. Good. So I'm going to circle a 2 in each of them, or highlight. What else do they have in common? Charles. What else do they have in common? Oh, now the light bulb's going off for some of you again. Is that it, Justin? They all what? Sure. GCF, the greatest common factor. In other words, the largest number that divides into all of them is 2 times 3, but you write down 6. The largest number that divides into all of them is 6. It's the greatest common factor. Briar. Yep. Mm-hmm. So like if all of them also had a 5, Briar, like that wouldn't work in this example, but they all also had a 5, you would also multiply a 5. You just pull out what they have in common. You don't write down how many of each of them there are. You pull out how many they have in common. Sean? No. That's why when I was teaching you factor trees, I told you it gets a little tricky because I start teaching you guys GCF and LCM and everything kind of gets jumbled up. Greatest common factor, you take what they have in common. Prime factorization, you list all the prime numbers. Annalise? They all have 1, 2, and 1, 3. So 2 times 3. Then you would do 2 times 2. You take, okay, listen, whatever they all have in common. So if each of these had 2 2s and 1 3, you take 2 times 2 times 3. Okay, let me do another one. You only take what they each have in common. All right, I'm going to save the word problem for tomorrow. All right, let's go to, on the next page, letter B. Okay, letter B. Okay, Mary, what do you want to change 42 to? Can't. Okay, so 6 and 7. Matt, what do you want to change 55 to? Okay, so looking at both sides, looking at the red numbers and the blue numbers, what do they have in common? Adam. So what is it called? RP, relatively prime. They have nothing in common except for 1, so that means the numbers are relatively prime. Questions on that one? Okay, let's do a monomial so I can, let me find one that Annalise was kind of asking about. All right, let's do letter B on example 3. They're all pretty much the same. I mean, we do 1, we do 5, they're all pretty much the same. Okay, so this is a little tricky because of the variables. Okay, so we're going to change 12 to 3 and 4, and then the x's to x times x times x, and then the 4 to 2 and 2. 18, let's do 6 and 3, and then x squared to x and x. Okay, so let's highlight. What do they have in common? So Annalise, give me one thing they have in common. Okay, so let's start with they each have 2 x's. I'm going to highlight 2 x's. What else do they have in common, Doug? How many? 1. So they each have at least 1 3. What else? Emma M? Okay, so someone explain to me, what do we write down for the GCF? Annalise, what do we write down? What is the GCF? Completely simplified. Charles? Yep. Now, you're going to do this in algebra. The 9th and 10th graders are doing this right now. The greatest common factor, so when we start to factor polynomials, I wish I'd have you guys next year, but I probably won't. 6x squared is the largest number and variable that goes into both terms. This is a monomial. It's the largest monomial that goes into both. Annalise, did that make more sense with what to write down? Because you answered that one. Okay. Any questions on GCF? Emma? Yep. Now, I'm going to save the word problem for tomorrow because I need like 10 or 15 minutes to go through that with you, but that's okay. So I need you guys to open up your homework packet. Hey, what did I do with the homework page? Okay, to 4.2. No, hold on a second. Okay, take a guess. Yeah. Now, I just decided I gave you a challenge, which 28 is a word problem, but I only gave you 1. Here's why. I want you to think about it. See if you can kind of come up with how to do it, because when we do one of the word problems together tomorrow, it'll make your life a little bit easier, because that one has more information in it. What number is that, Adam? What did you put? Yes. Okay, so 2 to 28 even. Now, hold on a second, Emma. Some of you guys that write big, I suggest doing it on another piece of paper, because these are really squished together. If you make your factor trees, circle what they have in common. If you like to list everything, then still circle what they have in common. If you write big, loose, I'm leaving it up to you. If you write big or messy, like you can't fit everything, so if I ask you what an answer is tomorrow and you can't find it, not a good thing. Write it in your notebook or on loose leaf if you write big or messy. okay? Or you just like extra space. I fit it on here, but I write really small on here. So 2 to 28 even. Lesson was too easy. I need to make it harder tomorrow, huh? I don't know about tomorrow yet. I need to see how you guys do. Any questions for me? If you need to get your test